Hello everyone, a very warm welcome to this workshop, Blockchain Shala, conducted by the Blockchain Hive. Now, you must be wondering what the Blockchain Hive is. So, before moving ahead, let me briefly discuss what the Blockchain Hive is. We are building a decentralized education platform using blockchain and NFTs. Now, the owner of the content bought by the user will be the user himself, and he will be able to transfer and sell the course according to his or her own will. This will create more efficient learning. Let us wait for 5 more minutes till that everyone can join. Hello. Kindly let me know in the comment section that am I audible to all of you? Am I audible to all of you? Okay then, let's start. Hello everyone. First of all, a very warm welcome to all of you to this workshop Blockchain Shala conducted by the Blockchain Hive. Before moving ahead, you must be wondering what the Blockchain Hive is. So, let me give you a brief introduction about the Blockchain Hive. We are building a decentralized education platform using blockchain and NFTs. The owner of the content bought by the user will be the user himself, and he will be able to transfer and sell the course according to his or her own will. This will create more efficient learning by incentivizing quick learners and providing an alternative and cheaper option for quality education at a lower cost. Now, I feel that you have made the discussion to lead the workshop. Hold on, hold on. I know as of now, these words blockchain, NFT, decentralization might appear too complex to understand. But I promise that if you stay there and pay even 70% of your attendance, you will be able to hold on all these terminologies and how these functions. And if you want to become pro at it, believe me, strategies will be discussed later on what we are here for. Happy learning to all of you. Before we introduce our first speaker, I would like to mention that we will be sharing a Google form to track attendance during the workshop. This form will be circulated at any random time, and we kindly request all the participants to fill out the form to record your presence and get the participation certificate. So let's welcome our first speaker, Janesh Balchandani, who is lead blockchain developer relation engineer at Reeve. I would like to hand over my mic to Janesh now.
Hello everyone, am I audible? Hello, hello. Yeah, am I audible? Yeah, hi guys. Thank you for inviting me for the session. So, I just want to know that how many of you are new here, new about Web3 and everything, so that I can get a clear idea about how should I start the session and everything. And what's the language you guys prefer? Like it's English or Hindi? Just let me know. Okay. So, are we good to start the session? Should I share the presentation with you all? Okay. Okay, so many of you are suggesting I should start with Hindi. Okay, so hello everyone. Today अपन blockchain के बारे में बात करने वाले हैं. We are going to discuss about how the blockchains evolved, कैसे blockchains आई, and how they are moving forward in the tech, and why do we need blockchains. ये भी अपन आज समझेंगे, and more about the consensus mechanisms, the technicalities of blockchain. So I think we can start and move forward. Yeah. So tell me one thing. What do you guys know about blockchain? आप लोग कितना जानते हो blockchains के बारे में? Just you can share your bit, like कुछ idea होगा, कुछ भी होगा, तो you can share it in the chat. Anyone? Anyone from the audience would like to answer, like what is blockchain? Okay. So I can see that not many of you are aware about blockchain, so no worries. We can move forward. Let me answer the question for you. Yeah. सो ब्लॉकचेन कुछ भी नहीं है यार, ब्लॉकचेन इज अ कलेक्शन ऑफ डेटा एंड रिकॉर्ड्स व्हिच आर कनेक्टेड टू ईच अदर। अब इसको थोड़ा और डीप में अपन समझते हैं कि व्हाट आर ब्लॉकचेन्स। आप लोगों को एडब्ल्यूएस पता है? व्हाट इज एडब्ल्यूएस? Amazon वेब सर्विसेज या गूगल क्लाउड? How many of you know about AWS and Google Cloud? Okay, so I can see that you guys know about these. तो basically क्या होता है ना यार, these are servers. So if you look at them, they are centralized, like AWS and Google Cloud. आप लोग कोई भी वेबसाइट बनाओगे या कुछ भी एप्लीकेशन बनाओगे, आप अल्टीमेटली जाके AWS या गूगल क्लाउड पे डिप्लॉय करने वाले हो। सो वहाँ पे अपना डेटा स्टोर कर सकते हो, काफ़ी सारी चीज़ें कर सकते हो, अपने एप्लीकेशंस, अपने वेब एप्स, वेबसाइट्स, सब कुछ वहाँ होस्ट कर सकते हो आप। बट द प्रॉब्लम इज दे आर सेंट्रलाइज्ड एंड दे आर कंट्रोल्ड बाय द ऑर्गेनाइजेशंस कॉल्ड गूगल एंड अमेज़न। सो देयर वाज अ नीड कि यार ये सब चीज़ें काफ़ी ज़्यादा सेंट्रलाइज्ड हो रही हैं, एंड द प्रॉब्लम इज कि our data is in their control. कल को if anyone wants to shut down my whole platform, let's suppose I build a multi-billion dollar company and Amazon decides to shut it down, so they can completely delete my all data, and all my website will be removed from the internet and there will be no trace of it. So इस problem को solve करने के लिए यार, we all work towards a common goal of decentralization, and that is how the blockchain was created. So the blockchain की जो start हुई थी, it started as a cryptocurrency. It's a cash system. Like कितने लोगों को यहाँ पे BitTorrent पता है? टॉरेंट पे वेबसाइट्स डाउनलोड, मूवीज डाउनलोड की होंगी काफी सब लोगों ने। तो कितने लोगों को टॉरेंट के बारे में पता है? ओके, आई गेस काफी लोगों को पता है अबाउट टॉरेंट। सो जो बिटकॉइन है, बिटकॉइन इज ऑल्सो सिमिलरली बेस्ड आउट ऑफ बिट टॉरेंट। इट्स लाइक पीयर टू पीयर कम्युनिकेशन। इट्स लाइक मुझे और आप लोगों को अगर कम्युनिकेट करना है तो देयर शुड नॉट बी अ मिडिल party or middle person who is handling all the things. We can directly communicate with each other. That is what we call as peer to peer communication. Like I am one peer and you are one peer, so we both are communicating without any problems. So इसी तरीके से बिटकॉइन आया मार्केट में। सो बिटकॉइन वाज आल्सो डिजाइन्ड इन सिमिलर वे कि if I want to send you money and you want to send me money, we can directly communicate with each other, and the data of the transaction will be publicly available as a record for everyone to verify. So इससे एक तो सिक्योरिटी बढ़ गई, सिक्योरिटी इस हिसाब से बढ़ गई क्योंकि we both are communicating with each other and there is no middle party, so the network is already secured, and transparency बढ़ गई। So the transparency ऐसे बढ़ी कि यार the data is publicly available, so anyone can see what's the amount being transacted between one person and another. Yeah, it was launched in 2008, but एक fun fact मैं आप लोगों को बताना चाहूँगा कि जो बिटकॉइन है या ब्लॉकचेन है वो कभी बन ही नहीं पाती अगर 1992 में स्टुअर्ट हार्बर्ट और स्कॉट स्टॉर्नेटा, ये दो रिसर्चर्स थे, इन्होंने डिजिटल टाइम स्टैंपिंग का इन्वेंशन किया था। आप लोग जब भी अपने फ़ोन में फ़ोटोज़ या पीसी पे कुछ भी फ़ाइल स्टोर करते हो, तो कभी भी उसकी प्रॉपर्टीज़ में जाके देखोगे तो देयर इज़ ऑलवेज़ अ रिकॉर्ड कि ये कब-कब एडिट हुई है एंड व्हेन इट वाज़ क्रिएटेड, व्हाट वाज़ द टाइम, एवरीथिंग व्हिच वाज़ क्रिएटेड। सो ये जो चीज़ें हैं, ये 1992 में स्टार्ट हुई थी व्हेन द टाइम स्टैंपिंग ऑफ डेटा वाज़ इंट्रोड्यूस्ड। सो टाइम स्टैंपिंग क्या था कि कोई भी डेटा व्हेन यू आर क्रिएटिंग, इट इज़ टाइम स्टैम्प्ड, ठीक है? तो उसमें क्या होता है टाइम स्टैंपिंग में कि लेट्स सपोज कोई एडिट नहीं मार सकता। 1992 से पहले क्या होता था कि लेट्स सपोज ऑफिस में कोई काम हो रहा है एंड फाइल क्रिएट हो गई और मैंने फाइल आगे सबमिट कर दी। फिर वो फाइल आगे जाके कोई और बंदा एडिट कर सकता है, एंड जो तीसरा बंदा जिसको फाइल पहुंचनी चाहिए जो एंड गोल है फाइल का, जहाँ पे सबमिट होनी चाहिए, तो वहाँ पे उसको पता ही नहीं पड़ेगा कि ये कितनी बार एडिट हुई है, इसमें कितनी बार चेंजेस हुए हैं और कब-कब चेंजेस हुए हैं। सो दैट वाज़ अ प्रॉब्लम व्हिच इज़ इन ब्लॉकचेन एज़ वेल, कि डेटा को रिकॉर्ड करना है एंड स्टोर करना है। तो जो रिकॉर्ड है बेसिकली वो टाइम स्टैम्पिंग कहलाता है, कि किस-किस इंस्टेंट पे कितना-कितना ट्रांज़ैक्शंस हुआ है। तो ब्लॉकचेन इज़ already based out of, yeah. Yeah, many of you are requesting me to speak in English, and many of you are asking me to in Hindi. So I'll try to be in English so that you can better understand. So yeah, so as I was telling you that blockchain was created in 2008, but the stepping stone of blockchain was kept in 1992. So yeah, the version, not version control. Version control is a different thing. We'll talk about it more later. And what really happened was, so timestamping is something where you can timestamp the data. Let's suppose if I want to have a transaction between you guys, like we are communicating. So on the blockchain, if you are doing these things, it will be recording. Like it's 7:17 right now in my clock. So it will be recorded on the ledger that at 7:17 I'm speaking something something, and it is being recorded on YouTube. So this is something is happening. So because of timestamping, we were able to introduce the term ledger. So let us discuss these things further. I hope you are clear about when was blockchain emerged and how it emerged. What were the things that required? Are we clear on that, or you have any doubts? Okay. Yeah, I think we can move forward. Yeah. So the way we discussed about what are blockchains? The blockchains are similar to these AWS and Google Cloud, but these were centralized. So we wanted a decentralized way of communication and storing the data. So it is like I have broken the AWS server into millions of parts, and I have distributed those parts across the world, and they are connected with each other. So in this way, a chain is formed, and the chain is called blockchain, and each block contains data, and they are able to communicate with each other, and we are able to communicate with the blockchain. So in the similar way, we are able to communicate with AWS and Google Cloud. In the same way, we are able to communicate with the blockchains, and that is how we can communicate and access the data on the internet in a decentralized manner. I hope you all are clear. Yeah, the blockchain is much beyond crypto, and we're gonna see what are the applications that we can build on blockchain. It was introduced as a cryptocurrency or a peer-to-peer cash system, not cryptocurrency. Cash system is something where we are transacting the money, and the utility token is cryptocurrency. And now let us understand what are the core components of a blockchain, what are the technologies, terminologies, and applications are. I think we can move forward if we are clear. Yeah. So first of all, we can talk about the type and nature of blockchains. So currently there are two kinds of blockchains. वैसे तो तीन होती है, but on a broader level there are two, like private, public, and hybrid. These are three kind of blockchains which currently exist in the market. So let us discuss about these in detail. So what is public blockchain? So public blockchain is something which is publicly available and everyone can access it, and everyone has equal rights. अब इसको समझने का सबसे आसान तरीका ये है कि मान लो एक कम्युनिटी है, एंड इन अ कम्युनिटी एवरीवन हैज इक्वल पावर्स. तो उससे क्या होगा ना कि इफ देयर इज समथिंग न्यू दैट इज कमिंग अप एज अ डिसीजन, तो everyone will be involved in the decision process and there will be a voting, just like your डेमोक्रेसी। तो डेमोक्रेसी में क्या रहता है कि वी ऑल हैव द पावर टू वोट, द कास्ट द वोट एंड चूज द पर्सन एज एन इलेक्टोरेट, ठीक है। बट व्हाट इज प्राइवेट ब्लॉकचेन? सो प्राइवेट ब्लॉकचेन में देयर इज अ कंट्रोलिंग बॉडी who controls everything. It's like a group of board members in an organization that are controlling everything, and other who are the employees or the members, they have selected rights. So from the word we can understand what is private and what is public. So are we clear on the private and public blockchains? If you have any doubts, you can ask in the chat. So private blockchain is like a organization working on a blockchain level. Uh, for example, there's board member who is controlling everything, what is and who one should be given the access to anything, and the members or the employees who are there, they can access the things. So it's happening in a controlled manner. Whereas on a public blockchain, everyone has the access and everyone has equal rights to do everything. Okay, how was the blockchain created? So on a technical level, we are going to see the architecture of blockchain in the upcoming slides. So in that, we can have a better understanding how blockchains are created. So when everyone has equal powers and equal rights, so we always need a consensus. Can we trust private blockchains? Yeah, private blockchains are trust-based blockchains. They have their consensus mechanism. If someone is controlling how it is decentralized, it is decentralized in terms of power distribution, and the way we call it, it's privately decentralized. So there is always a governing body who is governing everything, but the votes that are cast, they are cast in a decentralized manner. So that is why we are calling it private. Timestamp is immutable in blockchain. Yeah. So the data which is stored, it is decentralized and everything is stored and nobody can change the data. Let's suppose even in a private blockchain, I made some changes, I made a correction. Let us understand it on a industry level. Let's suppose there is a company and they have their own private blockchain. So everyone is assigned, the employees are assigned some of the task. So what will happen is, if I am the manager and I don't want an employee to grow and have a growth in the company, so even if he submits me something, I won't submit it to my hires, my seniors in the company, and this will restrict the person's growth. So this will not happen in a blockchain. So if the employer has submitted the task, it will be stored on the ledger, and since nobody can edit the ledger, it will be directly submitted to the higher authorities, and that's how me as a middleman will be removed, and there will be completely decentralization. So that is how you can trust even the private blockchains. Is it clear with everyone that how private blockchains are safe, secure? Yeah, the blockchain is used to exchange data. For financial systems, which blockchain would be better? See, according to me, if there is a private bank which is going to adopt the blockchain technology, they can go with the private blockchain architecture. And according to the private blockchain architecture, you all can take a look at Ripple, RIPPLE. So Ripple is a private blockchain and it is helping out many blockchain companies. And so in this way, they are helping many companies to adopt the Web3 revolution and blockchain. So in the coming future, they will be empowering many banks, many international banks based out of Singapore and Europe. And you can see the blockchain architecture incorporated. So who validate blockchain, public blockchain, and how it's secure? So to understand this, let us move forward with the consensus model. So consensus is something, to on the layman level, what is consensus? Consensus, it's like we are agreeing upon something on some set of rules and some logic. Uh, can we please go back? We have to discuss the topics listed there. Yeah. So talking about consensus. So consensus is something we agree upon something. It's like there is a specific rule given, like when will the transaction be approved. So we are the two parties, and I want to transfer something and you want to transfer something. So once the amount is sent from my end and you have received it, we'll agree on the blockchain. Yeah, we both have completed the task. Now what will happen on the blockchain level? There will be consensus. So the two popular consensus mechanism that are out there are proof of work and proof of stake. So what happens on the proof of work? So in the proof of work, machines or the validators have to run a mathematical model to verify a set of transaction, is it valid or not. In this case, what will happen? The correct transactions will be verified and the fake transactions will be nullified. So as a as a guy who wants to play with the blockchain and do mischievous activities, what I will do, I'll create fake transactions on the blockchain. You didn't define about. See, hybrid blockchains is a very different topic, and on the simple level, what hybrid blockchains are? Hybrid blockchains are a combination of public and private blockchains. So we can discuss it on some another session because it's a whole topic. So for you as a beginners, you can take a look at the public and private blockchains. So moving forward with the consensus mechanism. So consensus mechanism is something, it's a set of rules and functions that allow us to verify the transactions. So in the market, there are two popular networks called public blockchains and private, sorry. So there are two popular consensus mechanisms, proof of work and proof of stake. So consensus mechanism are run in the machine level. We'll also gonna see. So basically they run after the transaction is done. Let's suppose दो जने हैं, दो जनों ने transaction करी, and then what will happen? The validators on the network, they will come. So they'll come and they'll agree upon the transaction if it's verified or not. So what happens on the proof of work? So in the proof of work consensus mechanism, we require machines to run a certain algorithm to verify. And since we require machines to validate these transactions, uh, we faced a lot of problem in scaling the network, because what was happening was there will be a lot of time that was being taken to verify a particular transaction, because we want to increase the security, and since we are increasing the security, the mathematical computation is being getting difficult. To understand this, we can see it like this way कि यार जब कोई ट्रांजेक्शन हो रही है तो क्या होगा कि with the time security बढ़ाने के लिए on the network, because blockchain is all about security. So what will happen is that more and more security layers will be added. So the जो mathematical question है, जो mathematical algorithm जो validators को solve करनी होती है, basically machines को solve करनी होती है, वो और ज़्यादा difficult होती जाती है. तो इसको कम difficult बनाने के लिए we used a different consensus mechanism which is called as proof of stake. तो proof of stake में क्या होता है? What happens on proof of stake? You stake a particular amount to verify the transaction. So here we don't require machines to do the validation, and they can easily verify on the basis of the amount that is being staked. तो जितना ज़्यादा amount stake किया जाएगा उतने जल्दी validations होते जाएंगे. So consensus कुछ भी नहीं है, it's just a way of agreeing upon something. तो agreement यही होता है कि the transaction is done. So are we clear about consensus? You guys can do a deeper down research. Due to time constraint, I'm not stretching the session. We have a lot to cover. So you guys can take a look at proof of work and proof of stake. Stakes are the tokens basically. So we stake a certain amount in a way that the validators take amount that we won't do anything that is against the system. So जब अपन स्टेक करते हैं तो स्टेक करने से क्या होता है कि इफ आई एम पुटिंग अ लॉट ऑफ अमाउंट, let's suppose I have put in $10,000 of my own in the system. So in order to make it secure, I won't be doing anything wrong with the system. If I be doing anything wrong, my $10,000 will be gone. So as a validator, I have to preserve my $10,000 and verify actual transactions and not fake transactions. So I will never do anything that will harm my $10,000. And validators are rewarded for their transactions. It's like mutual validation, yeah. And validators are rewarded for verifying the transactions because they are doing a lot of work, so they are getting rewards. So there's another thing that now I think we can move forward on the architecture, virtual machines, nodes, and miners. And so now we can take a look at the architecture of blockchains. Can we change the slide? Yeah, next. So now we are going to understand the blockchain architecture. Yeah. I hope you are able to see what's given here. Like there is a diagram of Web 2 and there is a diagram of Web 3. So what happens on the Web 2 side? There is a client side where the application front end is, and there is a server side where the logic is there. All the app logic is being called and data is being stored. Okay. And on the Web 3 side, so stake is given once only for all transactions. Yeah, it's done before the transactions are there, and you can validate. So become you if you want to become a validator on a blockchain and earn rewards for validating the transactions, you have to stake an amount. It is not related to the transactions and everything. Can we zoom it a little bit, the diagram? Hello. Hello. Am I audible? Yeah. So I hope it's visible to you all. So as you can see, the Web2 architecture, and there is a client side, which is the front end, which we all are using, and another one is your back end. So we can take it like at this front end and back end. So these two are directly connected. So what's your back end? So in the back end, everything is being stored on the from front end to back end. Everything is stored on AWS servers or Google Cloud or any other hosting services that you can take a look. So in this, what has happening? They are always stored on a centralized server, and to avoid the problem, Web3 was introduced. And what is happening in the Web3 architecture is that the front end and the back end is being connected by the blockchain, as you can see right there with the blue lines, that there is a blockchain server which is being connected with the front end and your back end. I'm not going too deep into the architecture, and because you guys will be little bit bored with this, or you want me to take a deep dive into the architecture. If you want me to take a deep dive into the architecture, you can give a thumbs up in the comments, and I'll explain it more. Okay, so what really happens on the Web2 side is whenever we are accessing the internet. Okay, so what happens on the Web2 side is whenever we are accessing the internet, we always interact on the client side and the browser. So let's suppose we are using Google Chrome or any other browser. We we write, let's suppose, YouTube, youtube.com. So what will happen? So YouTube front end will appear. So where is the all? So we'll start accessing YouTube and we'll start watching the videos, and we start watching the live stream. So what is happening? The data is being stored on a centralized server of Google, and you are accessing it. So you are exposed to Google. Like, this is the mail ID. Like, it's if there is an account on my name, like Janesh. So what will happen? Google will know what kind of content I'm watching and how my data activities are, how I'm accessing everything. So it will create a pipeline and funnel for me, and it will start showcasing me ads and everything in such a way that I want to watch. So what will happen in this case? Everything is stored on on the centralized server, and there is a problem of decentralization. Because there is no decentralization, we want something where our identity is not there and we are secured. Or you can see it like this also: whenever you are accessing a new platform, you are always asked to fill up your Google Mail ID. And whenever you are filling up your Google Mail ID, they will tell you that we are going to take your data, we are going to access your data and activities that you are going to do on this platform, and you have to agree yes no matter what, and you always have to agree. I'm going to come on the RPC. Wait. I'm currently talking about Web2. So have you all seen this? Like, whenever we are accessing something on the internet, we have to fill up the mail ID, and they ask us that we are going to take your data. Okay. Yeah. So they always take the data, and they force us to complete the terms and conditions page, and we cannot move forward beyond that. So it's all the problem with how we are accessing the internet. We are always accessing the internet with our mail IDs, and which is connected, and it is creating our identity on the internet. Now if we are moving forward on the Web3 side, we can see that whenever we want to access something on the client side, there is a wallet. You can see that there is something called wallet there. So what really happens? This wallet creates an anonymous identity on the internet, which helps us communicate with all the applications in an anonymous manner. So nobody knows who I am. And so wallet is your cryptographic address. It's just an alphanumeric digit code which is generated randomly on the internet, and anyone can generate that and use it. So in this way, our identity is preserved. Like nobody knows who is Janesh on the internet, and I can access the internet in the way I want, and there will be no data funneling created. And but sir, wouldn't there be a footprint? Yeah, there will be a footprint, but of whom? Nobody knows na ki whose footprint is this. Nobody will know that Naman is accessing the internet and it's the footprint. Yeah, it's kind of like Tor. Like Tor is a different discussion. So what happens on the Tor? Your IP address changes. So let us understand this in a more detailed manner. So whenever we are accessing something on the internet, there is an IP address connected. Yeah, IP address also not really revealed in wallet is used. Yes, that is the good thing, that nobody knows what's the IP address. Whenever we are accessing something, there is an IP address of our system, and on the server side there is an IP address. So IP address is the entry point and the exit point where the communication is being established. So in this way, the both the points are connected and there's a communication between them. And to avoid the problem, everyone knows that the server knows which device is being accessed, and we know that we are accessing something. So in this way, our whole identity, our system's identity, as well as ours and our own identity is exposed on the internet. Yeah, it's risky, and it's happening on the web 2 side. So to avoid this, we have web 3. So in Web3, what happens? There is no IP address that is being tracked, or nothing is being exposed. So everything is happening with the help of a wallet. Are you guys clear on this? Like, to avoid all the problems of IP address, data privacy, and everything, we eliminated the use of email IDs and everything with wallet. So wallet gives us an address, and that address allows us to communicate with the applications that are on the blockchain and on the internet. Okay, so what is RPC? Someone was asking me what is RPC. So RPC is nothing but a remote procedure call. So since we do not have IP addresses here, we make a RPC call, remote procedure call. From the name itself, we can understand that we are remotely accessing something on the internet. So remotely procedure call is something that we all are doing, like a phone call, like a message call or a WhatsApp call or anything. So it's called, I'm calling something on the internet, so that is what we call as remotely procedure call, RPC. So we are making a request, and we are getting back a response. You can see there are two things written: RPC request and RPC response. So what is happening? We are requesting the internet to give us the data, and we are getting back a response from the blockchain server. Contact anyone if we lose anything. Yeah, that's the one trade-off. Like, you cannot contact anyone if you lose anything, so you have to be careful, because if we are handling everything on our own, so we can't rely on someone. We used to rely on Google, Facebook, Amazon for our data, but here, as we are the owner of our everything, we can't depend on anyone. So for the data exchange, there is an address that is being generated on the chain. Rather than using a mail ID, we are using an address. यहाँ तक क्लियर हुआ सबको? with the help of wallet addresses, we are able to communicate with the data on the internet and our identity is not revealed. Okay, so should we move forward or you have any doubts? How to create wallet. So if you want to understand how to create a wallet, you can just simply type on the Google MetaMask, METAMASK. So MetaMask is the wallet on Ethereum and many other chains which you can access. Yeah. To access Web3, we need to have a wallet. Yeah, we are the wallet owners, so we know the details and nobody else knows our detail. MetaMask. Let me type in the chat if possible. So it's MetaMask, Meta, MASK mask. Yeah. So I think we can move forward since we are clear about the architecture. Yeah. So now we are going to see what kind of applications we can build on blockchains. So we can create any kind of application on blockchain which we are currently using. Like we can create our own social media platforms on blockchain. We can create a transaction platform like Google Pay or Phone Pay on blockchains. We can create any other kind of application. Like even games can be built on blockchain. So these are many kind of applications that we're gonna create. And to take a look at this, you guys can check out what are NFTs, non-fungible tokens, what are crypto and tokens, everything is there. So you can check that out. So everything is built on the contract level. So there's one thing called contracts. So contracts are nothing but your code base. So whenever we are creating something, we have to write a code or a contract, which is the application logic. So if we are building, let's suppose a social media on blockchain, we need to write a contract like how the post will be created. So even if we are creating, what is the difference between RPC and wallet? So RPC is nothing. It's a call basically. It's like a way of communication. Like in IP addresses, we are making a communication between two different IPs. In similar way, the wallet is commanding the blockchain. Like I want to communicate something with you. So this is what we call as RPC, remote procedure call. From the name itself, we can understand. So there is one thing that is remote. Like remote is something when two objects are disconnected from each other and they don't know the location. So that is what we call as remote. And a procedure call is something we are calling something one in a procedure manner. Like I'm making a process and I want to call the process. Like, hey blockchain, I want to call something. Can you help me out? So this is how I'm making a call. It's nothing, it's like a phone call only, and two machines are interacting with each other. It's a way a machine can communicate with each other. I hope you understand. Is it clear? Like what is RPC and what is wallet? Wallet is something that generates your address and store your cryptocurrency and all your tokens in that. Whereas RPC is something when we are calling a command. So how will we connect different decentralized systems to each other? Yeah, so to connect different decentralized systems to each other, that is, we are having a chain network, and it's like how the systems are connected through RPC calls only. It's like one server is communicating with each other. So there is, where do we use the contract? So contracts are used to build the logic for any kind of application that you want to build. And we are going to see that contract is nothing, it's a code. For example, if I want to build an application, I will have to write a code now. If I want to build a social media platform like Twitter, Facebook, Instagram, I'll have to write a code. So the code in blockchain or Web3 is called the contract. It's just the name that is being changed. Can you share some application names like social media with one example? Yeah. So there is one application called Wrapcaster or Farcaster. I'm just going to show you guys how it looks on my phone. So so you can see that this is a social media platform where there is a home page where all the chat is happening, like people are sharing their posts just like Twitter and Instagram. And this is completely built on blockchain. And the post you are writing, that the people are writing the post, they are stored on the blockchain. So this is a platform called Wrapcaster, Warpcaster, Wrapcaster or Farcaster. So this is one of the social media app that I am currently using. And to create this, I have to connect my wallet. So here you can see that there is a thing called connect address. So if I click on this connect address, it is showing me my wallet address that is connected, and it is asking me if I want to connect a different address or if I want to disconnect. It's replacing my mail ID and in the application, and in the application I don't have to type anything. So it's connected there. So you can see that there are number of followers, number of following. It's similar to a social media platform, but it is completely decentralized. Yeah. So what are NFTs? NFTs are non-fungible tokens. What does it mean by anything which cannot be created multiple times? It's to understand it clearly, it is like your identity card or anything. Like you can create applications like Aadhaar card or any other identification based things or any unique artifact. What the word fungible means copy, or you can have multiple formats of something. That is what we call as fungible. And the word non is we cannot create multiple copies or we cannot create multiple things. Like it's like your Aadhaar card. Like your Aadhaar card is unique, you cannot have multiple Aadhaar cards. Yeah, YouTube, WhatsApp, everything is created on blockchain. And to understand this, in this we have a private messaging app as well. So in the same application, I have a private messaging area where I can communicate with as many people as I want, who are my followers. I can communicate with them. I can write text. I can do anything. Okay. So NFT is nothing. It's a type of logic only. It's a type of contract which cannot be created multiple times. It is uniquely built contract. You cannot have multiple copies of this. Understood? What is unique in that art which prevents copying art itself, something in their code and backend? Yeah, so in the you will be getting a number basically. It's a mathematically generated number which will help you uniquely identify your NFT contract or any other contract. It is something like a stamping. So Web3 is a new generation of internet, like Web1, Web2, Web3, and there will be more applications or more generations coming in the future. And blockchain is a part of Web3. Like it's the technology, and Web3 is the generation. So I hope you guys are clear with the applications that we can build. So we can build any kind of, yeah, NFT is also a code. Then so it's a different kind of code. It's similar to your, like, for the social media platform I have to write a different set of code, and for NFT I have to write a separate set of code. To understand this, you can explore ERC 721. It's a NFT contract basically, all the three webs. So to understand what is the difference between all the webs, It's like Web 1. If you all aware about what happened in the earlier days of internet, you can just go and read something. That was Web 1. There was nothing interactive. So it was like Wikipedia. You go on the internet, you search something, and there is something to read. You cannot interact anything, you cannot communicate with any person. That was Web 1 in the early days. To understand what Web 2 was, Web 2 was something which we call as an interactive area, where we start interacting. Like Facebook was introduced, Orkut was introduced, or many other social media platforms were introduced, where we could interact with people, where we could chat, where we could share our ideas. So there was some kind of interaction. That was Web 2. We could post something, we could share something. That was Web 2. But the problem that arose in Web 2 was centralization. Everything was controlled by these companies. And then there came Web 3. So this is how the generation is being changed and the technology is being changed. Yeah. In some way, we can say that AWS will be replaced by blockchain. Yeah. So are we now clear with the applications of Web3 and blockchain? Yeah, so for that you will have to understand cryptography, the mathematical operation. We can obviously discuss about it, but if we go too deep into this, this is what we call as cryptography. No, it is not related to the problem that you have studied in your college. It's called cryptography. It's called encryption and decryption. Those who are from the computer science background, they might be having a subject in their higher semesters called cryptography, in which you can see how the data is encoded and decoded. Yeah. So example of blockchains like you gave about social media. So we are going to discuss about this in the further slides. Can we move forward? Yeah. So we can see there are multiple applications like code, ledger, and crypto, which we have covered. Can we move ahead as well? Yeah. So now we can see what kind we are going to see two popular blockchains that are currently out there. If someone gets a hand on our wallet, then they would still have an entire history. Yeah, they'll get the history as well. So it's better to secure your wallet. Ledger is something where all the transactions are recorded. Ledger is like your khata book, where all the transactions. It's like जब आप शॉप पे जाते हो या कहीं भी स्टोर पे जाते हो तो there is a book which is keeping the record. So ledger is something where all the records are stored. We can move forward with the slide. Uh, can you go? Yeah. So now we are going to see there are two popular blockchains out there. So one is Ethereum and one is Solana. So both of these are public blockchains. They use different kind of consensus mechanisms. Proof of work is being used by Ethereum and proof of history is used by Solana. And similar to your servers, there is a machine out there. Yeah. So it's similar to your machines that like the laptops or the systems, but we call them virtual machines basically. So why we call it virtual machines? Virtual machines is the ones that are running on a system, and they have their own architecture. So it's the design of a system, because to run an application we need servers. So every server has their own design, and in similar way we have different architectures in blockchain as well. To write everything like the code base, we have different programming languages. So So for running JavaScript, we need some different kind of system. For Java, we need different system. Even if you're in your colleges, you might have used C, C++. So for every blockchain, you need for any code base, you need different kind of compiler. Are you all aware about the compilers? Yeah. So for different blockchains, we need different for different programming languages, we need different kind of compilers. Virtual machines are the blockchain part of the map we saw. Yes, different virtual machines that are joined together, they make a blockchain. It's like multiple systems are there. Like whenever you go to your computer lab, you see all the systems are connected. Like in my school, what used to happen, all the computers that were out there in the lab, they all were interconnected with each other to communicate the data. So in this, we can understand they were forming a kind of a blockchain where all the data is being shared with each other. And as we can see, every blockchain has their own programming language, and these programming language require different kind of compiler design. So we have different kind of names for everyone. Like for the Ethereum, we have Ethereum virtual machine, and for Solana, the programming language is Rust. So for Rust, we need a low level virtual machine to compile and decompile the Rust programming language. And what kind of contracts that are being used in these languages are that one is ERC, that is used in Solidity, and in Solana we use Solana program library, which is based on Rust. You all can read more about Solana and Ethereum on the internet. Because of the time constraint, I'm not going too deep, but these can be the starting point of if you want to start building in blockchain or start getting into the blockchain world. If you want to start coding, you can get into Solidity and Rust. Most of the people prefer Solidity and Ethereum because it's easier to learn. C++ is used for blockchain development. Uh, C++ is not popularly used by any major programming major blockchains out there. So there are two kind of developers in the Web3 industry. One is a smart contract developer and one is a blockchain developer. Okay, so the smart contract developers have to follow different programming languages, and blockchain developers has to follow different kind of programming languages. One is so building blockchain, a blockchain developer builds the blockchain architecture, it builds the machine. Like somewhere someone is building your Windows operating system on which you are running your applications. So building blockchain is similar to building a Windows operating system where all the applications are running. And to build applications on top of Windows, we need software developers. So here we need smart contract developers to build applications on the blockchain. I hope you can understand. So C++, it's not popular. So what is EIP? EIP is a format of writing contracts on Ethereum language. It's another level of deeper discussion, which we might have in the future sessions. No, today we are not going to have any hands-on workshop, but hopefully in future. So I hope you are clear what is Windows and what are the applications built on top of Windows and what is blockchain and what are smart contract developers. So everyone uses different kind of programming languages. So if you want to become a smart contract developer, you can start with Solidity or Rust programming language. And if you want to become a blockchain developer, you can start with Rust or Golang. You guys can explore more on the internet and you can share your doubts with me if you have. But due to time constraint, I think we can move forward. If you have any doubts, you can ask me right now, or we can move forward. Can we change the slide? Yeah. So as you can see, for preparing yourself for Web3, you need multiple programming languages. You can see there is JavaScript, there is React, there is Solana that we discussed, there is a Golang programming language, there is Rust, there is Solidity, there is Ethereum. So all in all, we need a proper roadmap. I have a proper roadmap, but due to time constraint, I'm avoiding all the technical things. I just wanted to give you an overview of blockchain. So I hope you understand what is blockchain, how it is built, how we are using it, and how we are operating it. I hope the further sessions will clear all your doubts, and we can change the slide. So yeah, we can change the slide. So I wish you all to take the high road and start building in Web3. Next slide, please. Yeah. So there is a quote which we all understood in the beginning, like from the data centers, we are moving towards blockchain. So from the data center to the blockchain. So you can always remember this quote. Like right now, the industry is being evolutioned into somewhere we are now moving towards blockchain, and we are avoiding all these data servers, centralized server systems, and everything. So whenever next time someone asks you what is blockchain or what is Web3, it's all about we are moving from data center to the blockchain. We can move forward. So if you have any questions, you can follow me on my LinkedIn and my Twitter, and you can ask me doubts there. I'm always available on my LinkedIn to answer your doubts. I hope you all enjoyed today's session. You can scan the QR code and you can follow me on the socials, and you can ask your doubts there. Yeah, how to start learning blockchain? You have to start with learning about web technologies, which is like JavaScript. So you can always start with JavaScript and you can move with other programming languages. So if you want to get into Web3, you always have to start with the web development. So web development is a different area, and I hope the further sessions will be covering everything about how to get started building in Web3 and all. Yeah, JavaScript. So you can start with JavaScript and Solidity. Karan, I think we can wrap up the session if no one has any doubts.
Firstly, thank you, Janesh, for this insightful session. Now, I would like to first mention that your participation certificate is still waiting, so stay connected. Now, I think that every one of you is confident about what is blockchain. Now, moving further on, what are the use cases of blockchain? I would like to welcome Kamlesh Nagware, who is CTO Blockchain at Snapper Future Tech. He is among the top 30 influencers of blockchain in India and founding member of India Blockchain Forum. I would like to hand over my mic to Kamlesh. Thank you.
So, Mahek, are you going to introduce or shall I start?
Yes, Kamlesh, you can start.
Okay. So, are you going to move the slides or can I use my presentation? If I can use my.
You can use these presentations. Yes.
Yeah, so I'm starting my own. So better I can move accordingly. Okay, yes, so hi all. So, first of all, nice to be here and thank you, Mahek and Karan, for inviting me here to talk about the blockchain, introduction to blockchain, and the uh, kind of uh, what is blockchain history and the attributes of blockchain, types of blockchain network like Bitcoin, Ethereum, Hyperledger, and then use case and some adoption perspective, especially the enterprise kind of use cases. I'm going to discuss. Let me check the slide is correct or not. Correct. Okay. So I think I seen previous presentation where the Mr. is talking about how you can learn the blockchain and like maybe learning JavaScript and all other stuff and fundamental between the Web 2 and Web 3. So I'm going to add the little more data specific to the users of blockchain beyond crypto and beyond just tokenization. So so let's start with first my introduction. So I'm a CTO of one blockchain company and part of several other initiatives. Like I'm part of the uh, Center of Mentor to Blockchain or Center of Excellence by APIARY, which is a Center of Blockchain by Ministry of IT and Telecommunication and STPI. I also uh, part of couple of different universities as mentors. So as a mentor to the University of Petroleum as the advisor and couple of things. So and I lead the Hyperledger India chapter and has been part of the Hyperledger Technical Steering Committee. So Hyperledger is enterprise blockchain frameworks. So that is about me. I have around 12 to 13 years of experience and 7 years in blockchain. So I started in 2016. So, so let's start. So, what is blockchain? So, I think, as per my definition, I think blockchain is immutable time-stamp record stored and managed in different computers at the same time. So, some kind of distributed database, typically, but it offers couple of things like smart contract, consensus, and all these attributes offer a few characteristics which make the blockchain is a prominent technology for solving a trust and transparency issue. So I believe where we can see trust and transparency is a requirement of any use case. It could be government to the supply chain to the banking, or it could be anything where we see the need of trust and transparency and want to remove the bottlenecks or we can remove the third party. We can use the blockchain. So first, like blockchain offers a security. So security is inbuilt in blockchain because from communication, peer-to-peer communication to uh, data storage, always uses the cryptographic algorithms, PKI infrastructure. So your node has a blockchain node has their cryptographic identity and what is the data you are sending between the nodes. That is also uses the ELS layer and even the data you are stored in a ledger that is also cryptographically cryptographically signed and cryptographically encrypted. So typically SHA-256 is a typical one kind of algorithm uses most of the blockchains.
And another like blockchain is a word like block plus chain. So every data is appended to the or added to the previous block. So in every block there's the previous block's information. So it makes it impossible to change the data or impossible to modify the data. So that is provide the security. So two contexts as security. One is the storing data or communication between the nodes. Another is a blockchain characteristics, chaining of blocks. Uh, Another single source of truth. So because every node in the blockchain having the same exact copy or similar copy of data, so whatever the node you're accessing, you're getting the same data. So it's provide a single source of truth. So whatever the node you are trying to access, you get the same information. So this bring the truth of the data. Other thing, trust and transparency tools because is a distributed ledger, is immutable, is a cryptographically signed. So it provides the trusted data because consensus is used to store the data across the nodes, and data is transparent because uh, what every node having a same copy of ledger and integrated ledger with consensus by every node. And using all these characteristics, you could remove the intermediary parties from the business ecosystem. This is a typical definition of blockchain. So I think maybe I can recap. So how the blockchain is emerged. So the first Bitcoin paper in 2008, then peer-to-peer first Bitcoin transaction in 2009, and then after 2009, in a couple of years later, like Vitalik Buterin thought, like, why not use this peer-to-peer technology just beyond the cryptocurrency or beyond the Bitcoin? So he given a thought about the smart contracts. So this smart contract actually completely changed the ecosystem of blockchain, where you could program any kind of blockchain. You can program the business logics right in a smart contract, deploy on a Ethereum, and this emerged the concept of decentralized application in 2013 to 13 onwards. But all this era was a public blockchain. So lots of new cryptocurrencies, new exchanges, new tokens emerged, thousands of tokens being created during that period. And still now we can see the Ethereum is the leading public blockchain, and on top of couple of other layer two blockchain like Polygon is one, and many other. Even we now talking about the layer three, layer four kind of blockchains. And parallelly, there are couple of different public blockchain emerge like Algorand, like Near blockchain, like Federa, like this. But in a similar frame actually enterprises started thinking like why not just use technology uh, for only cryptocurrency and the public blockchain, because enterprises don't going never going to adopt the public blockchain that way because they need some kind of privacy and permission on their business network. So similar time there were even the Ethereum Enterprise Alliances emerged, and then the Quorum blockchain, and let's say Hyperledger Foundation founded R3 Coda. All is focused for enterprise and business specific use cases. We will talk about that in our last section in the presentation. So typically, if we understand this particular, I think this I'm using from last 6 7 years. So typically, every business network have a couple of different stakeholders, supplier. Let's say if I talk about supply chain, the supplier is there. There is a contractor. There is a bank. There is a supplier bank, buyer bank, and all the couple of regulator is create one complete business network. And currently, all business entity in the network having their own IT system even, not just Java, the complete IT system, and they transfer data each other via different mechanism. At the end of the day, do some kind of reconciliation, and that's actually causes the inefficiency or maybe delay in a transaction processing, and that's why blockchain is going to solve this thing. So let's now think about like there's a common database, all the entities is having part of the same network and agreeing on the terms and condition of the system. So instead of the reconciliation and the delay in the transaction process, now you could do the transaction as the immediate and real time settle. So you must be seeing like how the even like let's say capital market going from T plus 3 to T plus 2, T plus 1, and T plus 0. So the transaction plus settlement time. So because with the technology, you can reduce this settlement time, and it could be any business, not just only capital market or finance business. It could be your supply chain transaction, your trade finance, your export import, all the places. So this is the need of the blockchain in terms of business perspective. So typically, actually, blockchain offers all these characteristics, and any use case maybe use all, maybe some of the features mentioned here. So one is like blockchain is create the business network connected, and that will bring the efficiency. Efficiency because every participant in the network is connected and share the data and agreed upon on whatever the business and transaction and contract they are working on. So it will remove the bottlenecks or remove the reconciliation efforts. So it will bring the efficiency. Like for example, I mentioned about the T plus zero real time settlement transaction. Another is the data is shared across all the participants. So that is a transparency. So nobody can raise a question like this data is not the data I agreed or I shared or maybe you modify the data because everyone is in the same database or the same copy of the database. So they have to agree because they updated this data with their consensus between the node. Another kind of smart contract feature where you could write some business logic and your contract engine where it will execute the transaction, execute the business processes as per mentioned in the contract. So it will remove the third party or third party entities from the business transactions. You can imagine example of Swift network in the banking system, how the Swift network plays an important role where the cross-border payment feature. And that's why you must be hearing about CBDC going to change the cross-border implementation, cross-border efficiency using the distributed ledger technology kind of thing. Another is consensus, which is another critical part of the blockchain. So it will bring trust because consensus is a mechanism, agreement mechanism. Simply, if you understand. So every transaction, every data inserted in blockchain is approved and agreed upon all the participants. So that will bring the trust in the business network. Immutability, which is like the cryptographic and security feature of blockchain, because data is recorded in chaining format and cryptographically signed and encrypted. So there is a secure transaction, secure data. Another is a single source of truth because everyone is stakeholder having the same exact copy. So uh, in a it will help out to get the data any of the node the trusted which is a single source of the truth. So typically, if you combine this all the conversations, so blockchain is a distributed ledger, peer-to-peer compute, and no single point of failure because there are everyone holds the copy in the network, and is a mathematically introduced the cryptographic. Every block added as a next block in a existing blockchain, and every data is approved using the consensus mechanism. So all this is a blockchain definition. So typically, let me just walk through how the blockchain transaction works. So simply, if you this is common for every blockchain. Maybe some protocols changes, but it's a typically simple basic flow. Like when someone requests a transaction through a wallet application, it could be mobile wallet, it could be any internet browser wallet, where it initiate a transaction, which data or which uh, asset need to be added or modified or transferred on the blockchain. So and then it will receive by the any of the node in network, and that node is broadcast this transaction to all the nodes to validate it. At the number three, you can see like every node is validate the transaction and then create a block. So this consensus part is happening at number three, and this new block is created, and this new block is sent out to every peer to update their existing blockchain. So you can see that this uh, yellow block added in the existing chain, and then transaction completion message notification sent out to the client application like wallet or maybe user, like this transaction is completed in the network. This is a typically same for the every blockchain network, whether you are using a Bitcoin, whether it's a Ethereum, whether it's a Hyperledger. This is a typical same flow, but there are new feature or new layers added differently, but typically the same basic flow. This is not required. And consensus I just mentioned is a agreement mechanism between a stakeholder, and depending on the protocol or depending about on the requirement, there are various consensus mechanism, like quite popular in the field is like a proof of work, which is Bitcoin and Ethereum earlier, and then proof of stake, proof of authority kind of consensus mechanism emerge. And there are many such leader-based election like Paxos, like Raft and BFT and QBFT. Couple of things are there, but there is mostly users in the especially enterprise blockchain where you defining your own agreement mechanism, your consensus mechanism, you defining your nodes and their access, everything. But the typical public blockchain uses proof of the authority kind of. So that is there. So another last 6 7 years, couple of different blockchains deployed, like blockchain where is a public blockchain network. Anybody who is connected in out to the transaction can validate the transaction, see the transaction using the public blockchain explorer and a public blockchain, for example, Ethereum, Bitcoin, or Hedera or near blockchain kind of thing. And then couple of layer two, layer three kind of blockchain. Another is private blockchain where like Hyperledger, let's say R3 Coda, Quorum, a couple of private blockchain created by the basic uh, basic features of the any blockchain ecosystem. So like that. And then consortium where the business holder or kind of ecosystem, let's say insurance, banking, supply chain, automobile kind of companies come together and create a common consortium kind of blockchain where they can define the governance model, all the things. And now there is another four layer is not mentioned about the hybrid kind of the ecosystem is emerging nowadays, where public and private combination, because you can't solve every problem using public blockchain and you can't solve every problem using the private blockchain. So now businesses are started using combination of both together, where they're writing some part of business processes on a, let's say, private blockchain, and then using public blockchain as a proof of the transaction storing kind of thing. So hybrid blockchain kind of thing. So if we see the popular enterprise blockchain, so Hive, Fabric, R3, Coda, and Quorum. So not even thought like Polygon or the Ethereum is not a enterprise blockchain. Here I enterprise means the permission private blockchain, but enterprise is also using Polygon or other public blockchain protocol. So this is specific to the because so if you know the alchemy in a public blockchain ecosystem, kind of how it will infrastructure low code, no code platform for developing blockchain applications. Similarly, in enterprise blockchain like Hyperledger, Fabric, Quorum, there are some blockchain as a service offering by different cloud provider. Because it's very complex to run and build and maintain a private blockchain. There are it's a hybrid application. So this is a kind of introduction to blockchain. Starting with specific use. So, so given a thought that one, I identified some use cases beyond cryptocurrency here. So you can see nothing is mentioned about the cryptocurrency and any public blockchain kind of transaction records. So I'm mentioning about enterprise adoption perspective, like what is a different kind of use cases. So uh, like insurance and banking, where we can see the like KYC, decentralized KYC, identity management, like uh, DID, credential management kind of use cases. So even like recently, uh, Indian government announced about the decentralized KYC in banking segment, banking sector, cross-border payment, like uh, whether using CBDC or any uh, system developed on blockchain to do the cross-border payment effectively, because currently cross-border payment is costly and it's a time-taking process. Interbank payment, like interbank settlement, like if one bank transferring money to another bank, and then how they doing their business. Currently, they are having their own database and manage their own processes. So coming all this bank on one some kind of one common network. So, for example, there is BCCIC. There is a one bank common banking infrastructure created in India for doing trying such kind of use cases. Trade finance is quite popular, where like export imports happening, letter of credit, for example, uh, letter of credit, like for example, buyer and supplier doing transaction between each other, but they don't trust each other. So generally, in current business processes, they need to depend on their some kind of banking partners, respectively, like sell supplier's banking partner or buyer's banking partner, and there is a cost of having a this banking involvement out there. And so there's a trade finance instruments now being created, like invoice financing, or maybe let's say a letter of credit on blockchain, where all these stakeholders come together and create a common network, so they can effectively and efficiently do the transaction with less efforts and less cost, and in a efficient time, like loan, so like loan management on blockchain kind of use cases. So this is generally in insurance and banking. Financial services like equity tokenization, bond tokenization, escrow accounting, decentralized finance. What are the financial services in traditional segment working could also be on blockchain using the DeFi. Then use cases in healthcare and life sciences, like pharma track and traceability of drugs, or let's say medicine, or health record management. So like currently, our health record is not even digitally that much compared to other countries. So, but how you could use a blockchain to distribute securely record this data, health record across the health providers, like hospital network, and insurance and researchers, all kind of thing. Uh, Organ registry kind of thing, or like clinical trial is quite active use cases, where I see a couple of people building on it, like because clinical trial where like any new medicine or new research happening on any drug or vaccine is very complex process, and there is no authenticity about those data points. And this clinical trial based application, where uh, the research organization partner having a share the transparent data about this clinical trials happening out there. Government is a couple of use cases like digital identities, but like suppose if you know there's a Digiyatra, this air travel application that is built on blockchain, Hyperledger kind of digital identity kind of application. Registers a birth, death kind of certificate, caste certificate. Even in Maharashtra, a couple of this kind of use cases already implemented on Polygon and Hyperledger. Digital voting, like election commission, and uh, some organization trying to do the kind of remote voting on blockchain, because if you see the current data, like mostly uh, the people, even like for example in my case, even I never voted from last 10 years, because my assembly in a somewhere in Madhya Pradesh, but I'm staying in Pune. So, and I never going to travel for a 600 kilometers for give a vote. So, such kind of there are millions of people not able to vote. So, election commission is trying some kind of a digital voting, remote voting on within blockchain. Asset track and traceability of any luxury item or maybe any food items. So, a couple of food traceability example like Walmart is one. There is a couple of companies like Wessex, or there are many such use cases out there in the food traceability segment, or in the textile traceability and carbon credit traceability. So many other things there. Land records is another use cases which even recently Tamil Nadu e-government has already started with the successful implementation. Even we did with the Andhra Pradesh government in 2017, and also doing with the Malaysian government. So there is an interesting use cases. CBDC, which is another RBI, or let's say every central bank's initiative. So currently, more than 120 central banks is already building on CBDC platform. Few are in production, few are in research and development phase and pilot phase. Manufacturing and supply chain, where asset track and trace, provenance of the asset, warranty management, sustainable supply chain. So all these use cases where you using blockchain for data provenance, or like warranty management. Let's say even uh, the most effective use case like predictive maintenance of any big any aeroplane, for example, or any bigger uh, unit of manufacturing. Already companies are trying it or building on it. So even like Boeing or like Airbus already building, even Boeing for their blockchain practice in Bangalore. Sustainable supply chain, like every business processes supply chain having some kind of carbon footprint generation. So it's throughout the supply chain from input material to the final product shipment, and even the other sustainability data factors about the labor involvement, about the water, renewable energy, everything. So now, and businesses are using blockchain to record all these parameters transparently uh, and trusted manner on blockchain, and then uses this data to create some kind of use cases around carbon credit, for example, or regenerative finance, climate accounting for the parameters. In media and communication, like loyalty programs, like digital rights, even like Telecom Authority of India is also having a in production network built on Hyperledger fabric from last 2 years, where it's kind of in Telecom Authority retail and so food authentication, track and trace, loyalty programs, shipping document like cargo track and trace in travel and transport, education where like certificate authentication or the macro credential, or tokenizing a talent. Like currently, I'm working with one company called Resumax, where we are tokenizing a talent. So that means like anybody can tokenize their profile and become part of this ecosystem, where anybody can stake and stake on their educational or their credible score. So there are multiple use cases. Agriculture is a larger use case in food traceability, seed traceability, carbon credit in agriculture space, mining, like asset ownership, raw material traceability is already there. Like Rwanda country started or using blockchain for their mineral traceability, uh, like cobalt and other materials. Real estate, where the new kind of use cases like fractional ownership, tokenizing the real estate, of the land or the property, or commercial fractional of tokens. So even currently I'm working with one company called Real, where we are tokenizing the real uh, real estate property like flat or like commercial complex, thousands of token, and the buyer can even invest up to 1,000 rupees to 2,000 rupees, thousand taxes, and that is stored data in blockchain. Tokenization is another bigger use. So I have a complete another set of use cases regarding the use regarding the tokenization. That I will explain. So, so if added this use cases, complete blockchain use cases, another enterprise use cases. So tokenization like cryptocurrency, interbank payments, cross-border payments, uh, coupons, gaming, utility token, for example, security tokens like security issuance, CBDC, where two kind of CBDCs mostly like wholesale CBDC and the retail CBDC. Wholesale CBDC like central bank issue CBDC to the commercial bank, and it's used only for the transaction between central bank and the commercial bank. Then retail CBDC like RBI issue digital, illegal tender of the currency, which is accepted in the kind of thing. So where it uses for general purpose, retail purpose. So how you use the UPI, you can use the similar way. How you use your fiat currency, you can use the way. Even I am one of the user using the India's retail CBDC, uh, where I can having a token of that currency in my wallet. Another stable coin, so we must have seen the USDC, USDT, and couple of peer-to-peer lending, mortgages, lending and borrowing kind of use cases emerged in the stablecoin or DeFi space. Another use cases like NFTs, so like digital asset, physical asset tokenization, gaming, IP rights tokenization. So all this stuff where you are using tokenization to tokenizing the any asset or any data. So cryptocurrencies to the NFTs to CBDC, all is that tokenization use cases. Enterprise use cases where you using blockchain for track and trace purpose, provenance perspective, identity management, or just maybe securing the data, or maybe smart contract engines like escrow, like digital rights, or identity management like KYC or other kind of use cases. So, so this one. So I just mentioned about the CBDC, right? So CBDC, even this is a bit old slide. Currently, around 115 countries already piloting and working on blockchain. So you can see this below uh, word map where you can see like 10 already in production running. There are 15 already in pilot, 24 development, 43 research phase, and even two cancelled also because it depend on the currency or their uh, their need of the digital ecosystem, and maybe they can sell their CBDC. So CBDC is going to be the next big thing in a digital ecosystem in digital uh, banking, and more larger use cases around the financial inclusion or cross-border payments or programmability. So this is like an example, like for example, like currently, if any money given to farmer or any specific purpose, there is no any uh, there is no any traceability whether the money is spent in a better way, the same way, or the first same purpose it was given, because you can't program the money. So using CBDs, you can program the money. Like you can let's say a token number this to token number this only going to be used for that purpose, and it will be accepted only by the let's selected vendors or selected merchants. All could be programmed because it's a token. What kind of programming you can do the NFTs or the tokenization, same you can do the CBDC. So this kind of use cases will be the definitely will change the digital ecosystem globally. Another example, like let's say currently, let's say uh, you can save the expiry date on money. So let's say if government or let's say commercial bank issue some money to some let's say some contractor, for example, for some specific purpose to like complete the project, and they can save the expiry date. Let's say it will be this money will be expired by this 6 months, then 6 months, then 6 months. So it, as you can imagine, like it will completely change the corruption everywhere in the globe, where you could program an expiry date, or maybe let's say if you identify like this money is maybe in hands of some terrorist. So you can also control that money because you have a digital control, and that's why. But there is can't be done in a physical case, right? Because it is a you can't control why I spend, but it is digital, then you can control, and that's why couple of economists also. I think most of the few of the economists actually also argue that like this retail fintech is going to be the privacy concern for the user because it can track data like the consumer using the money for what purpose and when and with whom, all kind of this thing. So maybe the privacy concern to the user, or another maybe it will give a complete closed ecosystem where even banks or maybe central banks can even decide whether someone can spend money or not on let's say some specific situation. So that's why it's a privacy concern for the other people also. There's some concern about it. But I think there are bigger use cases on the CBDC, and that's why every country is building on it. So another like use case I want to add about the NFT. So NFT mostly we heard about the NFT use cases, especially in art or art kind of only art and photos and pictures and videos. But NFTs have a largest use cases in the enterprise perspective, where like you are tokenizing a game, tokenizing let's say music rights, tokenizing events or sports. You can let's say you get NFT of luxury brands, luxury of fashion, let's say even in thing like NFT of MG Motors car or NFT of the Mahindra Thar, or even if you're using social media like Instagram. I'm mostly even using so in social media in Instagram and Facebook there is a digital creation, digital avatar is there nowadays. There is an NFT of your profile kind of thing, and you can use your digital avatar in the metaverse and sorry in Instagram and Facebook. Real estate, NFT of the real estate, where because you can see the transfer of ownership very easily when you transfer the NFT. Digital identity to connect, getting the identity of the person. And another use case is also working in reducing climate space about tokenizing the carbon emissions or tokenizing the climate financing or digital financing or blue bond or ESG reporting. Another use case is the metaverse. I think was interesting use case. So I think last year we talked about topic like how is change the complete ecosystem of the user experience, like how people move from Amazon and Flipkart e-commerce to now how they can again give the flavor of e-commerce to the metaverse commerce kind of thing. So where like say you joining a concert in person to the maybe let's say Google or maybe YouTube. Now you can go to the uh, virtual environment of the same concept, television and film, fashion and cosmetics, sports, where let's say you are even there is even like recently if you see the IPL in the IPL final break in between break, there's a complete metaverse created by one company in India called Metalog. One is also part of that company. So there we created the metaverse of the stadium of the cricket of Gujarat Cricket Stadium where the final happened. So now you can just imagine like currently let's say if you want to buy a ticket for watching a cricket match, so you be just buying a let's say ticket without knowing how the match will be look like, how much far from the pitch and how it will look like when you're sitting there. But let's say if a digital metaverse for the same stadium, and before buying a ticket, you can go and sit on the seat, sit on the stadium seat, and can view around it, how it will look when you will actually sitting there, and then you can make a decision to buy a ticket. And similar thing could be applicable for anything, let's say education or art or FMCG or like e-commerce or like automotive. Like for example, currently, let's say if you customizing your car, so you may be doing customizing car, or maybe what are the promises that it will look differently, and when you go, it looks differently, or maybe let's say suppose if you want to see the combination, let's say different color and different interior, but because there is no you can imagine and create currently whatever the color option given to you, you have to choose whether you, whatever you say them, they will create it for you, but you can't visualize how it will look like. So even we are working with Mercedes Benz around it to created their digital experience of buying, and I think mostly now this car website now having a similar kind of experience, but there is non metaverse. This is only the virtual experience, but you can use the metaverse where you can even experience the vehicle. Similar in the tourism. So, like before buying a ticket or booking a travel, you can maybe go to the metaverse environment of the particular tourism spot and find out how it will looks like and what are the different points and how it will actually looking there. So there are many such use cases like offices, like factories. So so metaverse is definitely is going to be thing, because what I think like how we human being moving from like physical stores to the malls and then malls to the Amazon and Flipkart. Similar, I believe we will going to metaverse and simply there is the customer businesses will go there. So that's why now branding and marketing is also it started happening in a let's say gaming zones, or let's say gaming virtual games or metaverse games where let's say if someone race car racing game playing, and in the roadside they can see advertisement of some companies. So and why I'm talking about the metaverse here, because metaverse is also uses the blockchain technology in the background. So this all this digital avatar is some kind of identity, which is blockchain identity. All these assets which we see in a metaverse environment, that is on as NFTs, like even NFT like so the car is NFT or photo is NFT, and another the decentralized space we see, that is also divided in some fractions. So people can own it by, let's say, suppose someone want to open a virtual office, so they need to buy some kind of NFT of the land, like decent land, the sandbox kind of thing, and then the payments or maybe the trusted ecosystem of this decentralized network could another blockchain layer. So that's why blockchain is very critical component in a metaverse environment. Other than the first is about the user experience or the virtualization of VR, yeah, nothing. So that's all. I think if anybody any question, I think they can ask. So this is about me. If you want to follow me, you can follow me on LinkedIn, Twitter. So let me share my. You can ask question in chat anything, because I'm technical person, but now mostly active in the business side actually. So if you have a doubt about, you can ask even technical questions too, or any question about CBDC, any question about future perspective of blockchain ecosystem, what I see, what am I believe about blockchain system. So this is my current, yeah correct. This is my LinkedIn, so anybody can connect. Let me stop sharing. Yeah, so Mike, so I have done. So if any question, then I can address. Otherwise, I think I check. Okay, so there are some question actually. Okay. And this question coming on actually okay. Yeah. So Sai Kumar asking about he's from IIT Indore. You are a user chosen on CBDC. Yeah, yeah. So I am one of the users. Let me show. This is my CBDC wallet. If you can see, I don't know. So just let me address some question. I think there are some question in the YouTube live also. I was there. So Matt, I think I will address the question here. So,
Yeah, yeah, sure.
okay, so about this metaverse and blockchain tech link, right? So metaverse is some kind of virtual environment, but we use blockchain for one is the NFT of that metaverse environment, another is the NFT of that asset in the metaverse, another is the identity management and payment. So generally, mostly this public blockchain like Polygon or other kind of blockchain uses the blockchain layer, like Decentraland is there, Sandbox is there, kind of thing. User is, so I'm a part user. Yeah, right. So that is I'm sorry. Will be, yeah. So Sai asked about the will be the offline functionality. Yeah, so there is a RBI working on adding the offline functionality, like where even without internet, someone can transfer the money, like how we exchange the notes currency the same way. CBDC wallet have any benefit or MetaMask? So MetaMask only wallet is a cryptocurrency wallet. CBDC wallet is a digital wallet for holding your central bank digital currency. So both are different actually. MetaMask is a different for cryptocurrency purpose. And CBDC is not a crypto. And okay, other question. What are tokens and tokenizing? So what are tokens and tokenizing means? So tokens like kind of non-fungible and fungible tokens, and that means like converting any asset in a some kind of digital representation. Generally, we can say, and tokenizing is the process how you create a tokens, any token of any sort of a token. Yeah, so I think this is the right question by like computational power is something which will generate more damage to the environment. So that is right, but there are hundreds of such use cases where people are using blockchain to measuring this or maybe creating new use cases. So even I part of the Hyperledger Climate Action Accounting SIG, where we are working on let's say carbon accounting, let's say climate financing, let's say measurement of the carbon footprint, uh, the, uh, all those things. But computational power is obviously it will damage the environment, but you can use the technology for other aspect also. So consensus and contract. So yeah, this other use cases I mentioned is the use cases I have created or I have seen or I've been observed in the industry. But there could be many use cases. So simply, I believe like if the trust and transparency is required in any of the use case, you can apply the blockchain there. Consider contract. Contract is some kind of your business logic of your blockchain. And consensus is the agreement mechanism between the while you want to update or insert the new data in a blockchain ledger. New comment. Uh, Readers, you what is the being is a student. So I think you can spend time about the scalability, because when suppose someone is implementing a application that much level for the billion people, or maybe there's a interoperability and the scalability is a more research area required currently in the blockchain industry. You can have a yeah. The digital forensic is also because when you doing the digital transaction or the crypto transaction or digital asset, the cyber security measures also required so much. So there are a couple of platform and companies also giving offering. You can understand the uh, digital transaction on a blockchain network. Yeah. So thank you, Mac. So okay, thanks.
Thank you, sir, for sharing your experience of blockchain. Everyone kindly fill out that form to get the participation certificate. I would like to mention that you will get a participation certificate if you will join the workshop for all the 3 days. So stay connected. Thank you to all of you for being a enthusiastic and fantastic Janta. Tomorrow, we'll be covering Introduction to Web3 and future trends and opportunities of blockchain. So stay updated and stay connected. Thank you.